Okay. So here we go. I titled this stream "Third Time's a Charm," since I was unable to do this thing twice in a row. And I think that's just because I was overthinking it. Okay, so let's read this problem. It says a polynomial function f, real coefficients, has the given degree zeros and solution point. Write the function in completely factored form and in polynomial form. Okay, so the first one has a 0 when x is equal to -1. It's degree 3. It has a 0 when x equals -1, and it has a 0 when x is equal to 2 plus I root 5. And then they also give us this data, which we'll use at the end. So let's find a function that has these zeros, and then we'll just shift it so it fits this thing, or stretch it rather so it fits that thing. Okay, so the first 0 is x equals -1. I'm dealing with a third degree polynomial, which means it's a cubic. And so I have this 0. Find the factor, I just add 1 to both sides. And so x plus 1 equals 0. So x plus 1 is a factor of my polynomial. So let me just put this over here. Plus 1. Now, if it's a cubic, that means the remaining factors are a part of a quadratic. So I don't know what that quadratic is, but it's going to have this shape. And a big part of the reason why I had trouble with this before is because I just was making too much out of it. I know that like I had here, x equals 2 plus I root 5 is a solution. But this actually looks a lot like the quadratic formula, which is -b plus or minus square root of b squared minus 4ac. And this is what we should expect all over 2a. Okay, this doesn't have the 2a thing in the bottom here. The denominator of this fraction is 1. So what I want to do is I want to make a few equations and make a system and try and solve that system. So I can see that this 2 is in the same place as -b. So let's set those equal. And I can see that I root 5 is in the same place as b squared minus 4ac. But I is equal to the square root of -1. And so I can just bring this inside. And basically what I'll get is -5 square rooted is equal to square root of b squared minus 4ac. So this is a nice equation, and actually I can just take away the square roots here. Let me do this. Say I square both sides. So we've got 2 equations. And then the third one will come from here. So 2a equals 1. Okay, so this is pretty easy. We can find a and b, and those will help us find c. So a equals, from this equation here, I divide both sides by 2, and I get a equals 1/2. And then from this equation here, I just multiply both sides by -1, and I find that b is -2. So I know a and b now. A equals 1/2. 2. Okay, so let's get rid of these. We don't need this anymore. We don't need this anymore. And then let's just plug those 2 values into this equation and then solve for c. So -5 equals b squared. So -2 squared. So I'm just substituting in this value. And then minus 4 times a. A is 1/2 c. And then this is -5 equals -2 squared is 4, minus 4 times 1/2 is 2c. And then we just solve for c. So what we will get, add 2c to both sides, add 5 to both sides, divide by 2, and we get 9/2. Okay, so c is 9/2. And these coefficients look kind of gross, but they solve this equation here. this quadratic set equal to 0. So I can just multiply all of those by 2. Multiplying, actually, let me write it out. So 1/2 x squared plus, minus 2 x c 9/2 plus 9/2 equals 0. If I multiply both sides of this equation by 2, I get x squared minus 4x plus 9 equals 0. And so this thing should have the same roots, or should have this as a root. And we can check that, but I feel pretty good about that. Okay, so here we go. These, this quadratic has this root and the negative 2 minus I root 5 as well. And then if we bring back in that original factor that we had, this should have the same roots as the cubic that we're looking for, but it isn't necessarily the same thing. We need to fit it to this point here. So the way I'm going to do that is I'm just going to say it has the same roots. If I multiply it by some number k, it's going to be equal to this thing. But it's when I plug in -2. So if this is our function, and I've got some k here, okay, f of -2 is equal to k times -2 plus 1 times -2 squared is 4 is -2 plus 9. And this whole thing should be equal to 42, since that's what we're told in this solution point here. So let's solve for k. Everything else is known. So we get k times -2 plus 1 is -1. Then we've got -2 squared is 4. -4 times -2 is +8. Plus 9 is equal to 42. And then we've got k times -1 times 12, 21 equals 42. And we'll divide both sides by -21 to cancel these, and we'll get k equals -2. So from this equation, substituting in -2, we get f of x equals -2 times x plus 1 times x squared minus 4x plus 9. And I think that the question wants it in factored form, and it also wants it in the full, like, multiplied together polynomial form. Well, I think this is fully factored if we have real coefficients. Yeah, real coefficients. So let's, well, I guess it'd be real constants. I think this is fully factored. They don't want to complex constants here. So let's just multiply these together and figure out what the polynomial form would be. So this is like the first answer. Then the second answer will have -2 times x squared times x plus 1 is x cubed plus x squared minus 4x squared minus 4x plus 9x plus 1. And let's combine some like terms. We'll get x cubed minus 3x squared plus 5x 1, and distribute our -2. -2x cubed plus 6x squared minus 10x minus 2. Okay, so let's check and see if this worked. This is f of x. So a couple of things I can do. Let's plug in our zeros. Well, I don't even know if I want to do that. That could be a big pain. Let's see if we fit it. Let's put in the -2. We'll get -8 times -2 is +16. 4 times 6 is 4. positive 20 minus 2. This is going to be 40, 60 minus 2. Does that work? Something went wrong. Multiply correctly. Oh, that's correct. What a bummer. Let me write this down. I really want to use this method, but there's like an easier way. Let me just check this thing. I like very much want to use that method. Let's go back to this quadratic because that would be the place where the error is at. So let's just say x minus 2 plus I root 5 times x minus 2 minus I root 5. See, they haven't given me that that's a root, so I really don't assume this. And then let me get rid of these parentheses. Get x minus 2 minus I root 5, so I just distributed the negative there. X minus 2 plus I root 5, same thing, distributed the negative. And then I'm going to use the associative property to just kind of reassociate these. And then let's call x minus 2 a, and then I root 5 is b. Now this is difference of two squares. We've got a minus and we've got a plus here, right? So this is a minus b, this is a plus b. So the product of this thing should be a squared minus b squared. That is x minus 2 squared minus I root 5 squared. And then this gives us x squared minus 4, or no, this would be x squared minus 2x minus 2x minus 4x plus 4, and then this will be negative 1 times 5 plus 5, which gives us, yeah. Oh, did I just do it wrong? I just done it wrong. X squared minus 4x plus 9. So I think I had minus 2x. Okay, so this is the quadratic. And let's multiply x plus 1 times x squared minus 4x plus 9. And we want to give this some multiple so we can fit it to that negative 2 point we got. I'm substituting negative 2 in for everything. And then we've got a times negative 1. This is 12, 21. It's 42. Okay, so I'm getting the same k. Okay. All right, so that solution works. Let's check this one. Negative b plus or minus square root of b squared all over 2a plus 4 plus or minus 16 minus 36 is, which equals minus I root 5 over 2. So we get 2 plus or minus I root 5, which is what we want. Okay, so the quadratic's good. And then, so this is the first answer. The second answer, we just need to FOIL this out. So we'll get x equals 2 times x cubed plus x squared minus 4x squared is 4x, it's 9x, it's 9. And then have some like terms here. X cubed minus 3x squared is 5x, 9. And distribute that negative 2. X cubed 6x squared is 10x minus 18. So let's check and see if I fit this correctly. Okay, so this would be 2 times 8, 16, instead of 12. This would be negative 20 minus 18, so negative 38. No. Oh, this is not 2 times 4. This is 4 times 4. Okay, so 40 is 20 is 20. It doesn't work out. Where have I made the mistake? So these things have the right zeros. For some reason, it's not coming out. Let me check this. So plus I root 5 squared minus 4 times 2 plus I root 5 plus 9. So this will be 4 plus 4I root 5 minus 5 is 8 is 4I root 5 is 9. Just cancel. 4 plus 9 is 13. Okay, so this is good. Let's be in my multiplication. So this is correct here. Let's try and plug in -2 here. Let's go. F of -2 equals -2 times -2 plus 1 times 4 plus 8 plus 9. And this is -2 -1 1, which gives us 42. Okay, so I must be distributing this wrong. Take more care with that. Okay, so this is correct. Okay, x plus 1 times x squared is x cubed plus x squared. X plus 1 times -4x, -4x squared minus 4x. X plus 1 times 9 is 9x plus 9. So x cubed minus 3x squared plus 5x plus 9. I think that's the same thing I had last time. Then we've got -2x cubed plus 6x squared minus 10x. Oh, this is not correct. Minus 18. Okay, so this is f of x. Let's see what f of -2 is. Okay, I think I was just making an arithmetic error. Goodness gracious. It's like I don't do enough arithmetic. That's defeating. Well, I should be celebrating. I finally got it. I think this is a little late for my student because she has an exam today. But I did show her the correct process. If I was doing the arithmetic wrong, that's a bummer. Okay. If nobody asks any questions, I think the stream is over. It's wild. I always get like 1 or 2 viewers. Every single one, I always get like 1 or 2 viewers, and I have no idea who it is. It could be anyone. And then like this one had playbacks too. Like, I can see it in the dashboard. It shows that I had some playbacks. The total number of times the video has loaded, including page refreshes and change of camera angle. This number does not increase when a viewer switches resolution. And very, very rarely does anybody ever chat. There were some people, like when I was regularly going on Reddit and finding people's like recently posted problems, they would come in, they would follow the link to the stream, I would drop them a link and they would come and ask questions and things like that, which was cool. So maybe I should get back to doing that. I'm programming a lot more lately. And so that's kind of like how I'm spending my time now. I haven't been streaming as much, but I wanted to, well, I think I've probably been clipping this entire time. I don't know. I never checked the audio, but I should probably go back and listen to it. Okay, all right. I think that's it for today.